Hi, hello, welcome to Math It a Go. Here we are on the third day of our 18-day action plan with the chapter Polynomials. Like the way we did with sets, we are dealing this session by going question wise, thereby gaining the knowledge of all the concepts that are dealt in the chapter Polynomials. Simultaneously, you will also learn how to solve these problems. This can help you to solve any kind of problems dealt in the chapter. This would be very much helpful in your examination and in your future. Taking the first question, is m square minus root 2m plus 2 m square minus root 2m plus 2, is it a polynomial or not? What is a polynomial? Before knowing what a polynomial is, we should go into a little of its background, where polynomials come from. Because the subject is mathematics, we deal with numbers exclusively, but as the scope of mathematics increases, you understand that the numbers alone are not enough. In that case, we have to borrow something else from some other place. So how do we do that? Sometimes we need to use something else instead of numbers. For that, we borrow some alphabet from some languages like English, Greek, and any other language. So this branch of mathematics, which makes use of numbers as well as alphabet of some language, is called algebra. What is algebra? Why should we use of alphabet instead of numbers? Because using alphabet instead of numbers generalizes things. See, if I say 2 plus 4 is 6, because 2 is even number, because 4 is even number, and I added 4 and 2, and 6 is also even number, so the result will be also an even number. If I say this is not generalization. This is only application for only these two numbers, but we can't say whether we get the same result in all other cases also. So instead of using 2 and 4, if you say if A is an even number and B is another even number, if you add them, you will get C, which is also an even number. This is generalization. So from this we can understand, if you add any two even numbers, you will only end up in getting even number. So like this, we will generalize mathematics using alphabet instead of numbers. Using numbers pertains only to that context, but using alphabet applies to all the situations. Hence, this chapter algebra is very important, and this is the most important and very vital part of mathematics. So let us see where it begins. So as discussed, we have numbers 1, 2, 3 and so on, maybe something else also, root 2 also, any numbers, the real numbers. We also make use of alphabet borrowed from some languages like English or Greek or anything, alpha, beta, gamma, etc. So these are the alphabet we use and these are the numbers we use. The numbers we use have the values being constant in any problem, any situation. 2 is always 2, no matter which problem you take, who takes the problem, and where they take the problem. So these have the same value wherever they go. So these are called constants because their values remain constant. But whereas these, because they do not have any value in mathematics, they can be assigned any value and their value varies from problem to problem, place to place, situation to situation. So for example, in a problem we find the value of x and it happens to be minus 2. And somewhere the same x may get the value 10. So the value of x is varying from place to place, not only of x, of all these, because they do not have any particular fixed value, their value changes, their value varies. Hence they have got the name variables. Variables can be changed, their value can be changed. Now these two are the constituents of this chapter, the algebra and polynomials. Polynomials is a part of algebra. So these two constitute the chapter algebra and thereby the polynomials, the numbers as well as the variables. Now let us see how they make things. Let us see. Mathematics is a language like any other language as Telugu, Hindi or English. We have alphabet which forms words, which forms phrases, then forming sentences and paragraphs and so on. Likewise, mathematics is also a language which expresses everything we speak and thereby solves the problems of our daily life. Let us see how. So, as discussed, x, y, z, etc., 1, 2, 3, half, root 2, etc., they form the basic of this algebra. Then, how do we call this? Let us see. So, for example, if you have a number, maybe 1 or 2 or anything, or a variable, or both of them together, or more of them together, we call it a term. We call it a term equivalent to a word in English. So, a constant or a variable or both or more kept together form a term. When we say 2xyz, it means 2 into x into y into z. There is into symbol in between them. And it also means 2xyz means xyz, this group is added 2 times. So hence the name 2xyz. This group is added this many times. This is also the meaning. Because from repeated addition of the same, we get multiplication. Hence, it is added 2 times, therefore we are getting 2. So now these are called the terms. In the terms, if there is a number preceding the variables, this is called coefficient. This is called coefficient of the term. And the coefficient may be negative or positive or whatever it is. It will be a real number. So, coefficient can be any real number. What are real numbers? It can be natural number, whole number, integer, rational number, irrational number, any of them. And from words in English we form phrases. Like that, in mathematics, from terms come expressions. For example, you add this one and this one. X added to 2. Now this one becomes an expression. Here, this one, both are terms individually, are kept together also, they form a term, single term. But if they are added or subtracted, that means using plus symbol or minus symbol, they form an expression. They form an expression like phrase in English. That means they have some meaning. So x minus 2 means what? This is 2 less than the x. So this is how we understand an expression. Now, if this expression has certain value, that is called an equation. How? Let us see. If this x minus 2 is equal to 10, so the expression added with a new symbol is equal to some value, this is called an equation. So, from a variable or a constant or both, we get a term. From terms, we get expression. Expression can have any number of terms. There is no limit for that. So, we get expression. From the expression, we get an equation. So, expression is different from equation. Now, this can also happen to be something like x square minus 2x is equal to 10. So, what happened here? We have terms combined by minus. So, this is an expression and its value is equal to 10. So, together, this is called an equation. And here, we have some variable with some power. We have variables with some powers. So there is a lot of importance for these powers. If the powers happen to be non-negative integers, non-negative, if the powers happen to be non-negative integers, then that equation or expression or term, we call it a polynomial. An expression or a term or an equation in which all the variables have non-negative integers as their powers, then we call it a polynomial. So here let us see, this is non-negative, means it should not be negative. So there is no minus symbol, so this is okay. So this is plus, this is okay. This is 0. So 0, is it a non-negative integer? Non-negative means it should not be negative. So there is no minus sign. So 0 can be considered as non-negative integer. So this is right. So this is together called a polynomial. Now let us take a case like x to the power of 5 and 1 by y is equal to 10. Is it a polynomial? If you observe carefully, this is a non-negative integer, the power of variable x, and the variable here is y, its power is 1. So we might get confused that it is also non-negative integer. But we should not consider having variables as denominators. Transpose it into a numerator and then only check its power. So we know this can be written as y to the power of minus 1 is equal to 10. So this should not be in the denominator place. Make it a numerator, then check its power. So this is negative. So this is not a polynomial. For example, if you have like this, x to the power of half is equal to 0. Is it a polynomial? See, the power is non-negative. So can we consider it a polynomial? See, it doesn't end with non-negative. It also has the tail called integer. It should be an integer. What is an integer? Natural numbers, whole numbers, and negative numbers. All these are called integers. So numbers with plus symbol, minus symbol, and 0. So there should be only 1, 2, 3. Not these, the fractions or decimals or numbers with roots, root 2, roots for example. So this is also not a polynomial. Now coming to the actual problem, is this a polynomial or not? Why? Now let us see, the variable is m here. So the power here is 2, it is plus 2. That means it is a non-negative integer. It satisfies our condition. Then here its power is 1. So 1 is also non-negative integer, it also satisfies. Here the power is 0, so it is non-negative integer, it is also satisfied. So this can be considered a polynomial. But here we have a root 2. So does it cause any trouble to our name called polynomial? No, because the definition specifies that the power of the variable must be a non-negative integer. It never specified about the coefficient. The coefficient can be any real number. So this is a real number. Therefore, it does not affect the name polynomial. So this is 100% a polynomial. So the answer must be it is a polynomial because all the powers of the variable m are non-negative integers. Therefore, this is a polynomial. Coming to the second question, what is the degree of the polynomial x to the power of 20? Now let us see what is a degree. A degree is the power of the variable. So where is the variable here? It is the variable. Its power is 20. Therefore, its degree is 20. For example, if it's given like this, x to the power of 1 by 2, what is its degree? So can we write its degree as half? No, because degree is considered only for polynomial, and polynomial cannot have fraction as power. So this is not right. Degree will be only in terms of 0, 1, 2, 3 like that. It can be any bigger number, but it won't be in terms of fractions, decimals, roots. Okay, so this is not at all a polynomial. So there doesn't arise the matter of degree. So what is its degree? It is 20. I have a question. What is its coefficient? It is not mentioned, so we take it as 1. So 1 is the coefficient, x is the variable, 20 is the power, or otherwise the degree here. Now, if we have one variable, you are considering its power as degree. Now, if we have a term with two variables, then what is its degree? Because we defined the power of the variable. Here we have two powers. Which power to consider? When you have more than one power, you will add up all their powers and consider that value to be the degree of the term. So you're adding 1 plus 2. So now this is 3. So the degree of this xy square is 3. Now if we have an equation, what applies? Let us see. If you have something like xy square plus y plus z to the power of 100, what is its degree? Should we add all the powers here also? No, the case is different here. When it is a single variable, we consider only its power. When there are more variables in the single term, we add up their powers and that becomes its degree. And when you have more terms, you will calculate the degrees of the terms individually. So what is the degree of this term? 3. Because 1 plus 2 is 3. What is the degree of this term? 1. What is the degree of this term? 100. Of these all, you take the highest one as the degree of this equation or expression. So we do the same in expression as well as equation. We calculate the degrees of individual terms and the highest of them we consider as the degree of the polynomial. Now I have a question. What is the degree of 100? Simple, it's 100? No. Let us see. The definition says it is the power of the variable. Where is the variable here? There is no variable. If you still want to see a variable, you can write it like this. Because any real number raised to the power 0 is 1. So it is nothing but 100 into 1, which makes again 100. So writing 100 or 100 x to the power of 0 both means the same. So now what is the degree of this 100? So this 100 is nothing but this, so its degree is 0. Therefore we say the degree of any constant is always equal to 0. The degree of any constant, be it 1, be it 10, be it 100, its degree is always 0. And a term with a single constant is called a constant term. And the degree of a constant term is always 0. Coming to the third problem. Find the value of the polynomial x cube minus x plus 1 at x is equal to 2. When we have a polynomial having all x as variables, we write it like this and call it p of x, polynomial having x as variable in it. So p of x can be written as x cube minus x plus 1. If it had been y here, we would say p of y. Now, he is asking us to find the value of this one at x is equal to. That means instead of x, you put 2 and find what value you get. That is his intention. So here instead of x, you write it 2. So p of 2 becomes the value of the polynomial 2. So p of 2 is also called the value of polynomial 2. So instead of x, you write it as 2 cube minus 2 plus 1. Now 2 cube is 8. This is minus 2. This is plus 1. Now this becomes 9 minus 2 and this is 7. Therefore, the value of the polynomial x cube minus x plus 1 at x is equal to is 7. Or you can simply say p of 2 is equal to 7. Simple. In place of x, the variable, you are putting the value given and substituting it and simplifying it. And this value is called the value of the polynomial at so and so value. Thank you and have a nice practice.